There was an article that came out in 1995, and it was written by Bruce Thompson, and he's an educational psychologist. And he basically, in this piece, gave three rationales for why computers don't do as good a job as humans in deciding the order of entry of predictors in regression. And so the first one, he argued, is that any computer method will inflate type 1 error rate. So basically it makes more predictors look significant in the model than there actually are. And this is because it does this iterative process and it doesn't adjust for the type 1 error rate at each step of the way. So it's kind of analogous to ANOVA when we're doing many mean comparisons and we have to do a correction so that we're not inflating our type 1 error rate. Related to this concern is a second concern, and that is that partially because of the type 1 error, this method, when we let the computer decide the order of entry, it yields results that aren't replicable in other studies. And so what we have is, if we have the same exact study done multiple times on different samples, these computer methods won't converge across those studies. And so that gives us a kind of a warning sign as to the veracity of the results that we're getting from these analyses. Finally, these methods of computer decisions regarding predictor entry into the model is that they don't identify the best set of a certain number of predictors that explain the most variance in the DV. So to my knowledge, there's no computer program right now that currently exists that allows you to take 30 predictors and tell the computer, I need the 5 best ones that predict the most variance. All of the different entry methods that are available, the backward, the forward entry, the stepwise entries, they do not give you that best set of predictors, and I will show you why in the next segment in a screencast. So just to review, there are 3 different arguments that Thompson has used and that I believe that are still used today. Lots of folks still cite this article to provide rationale for why we should not use these methods. The first is inflating type 1 error, and the second is that the results aren't replicable, which calls into question their accuracy. And finally, it does not identify the best set of predictors that explain the most variance in the DV. So again, if you have 30 predictors, it doesn't tell you the best 5. This is important, big picture again, this is important because clients may ask you to do these methods in order to find the best set of predictors, and I'm giving you rationale that you can explain to those who don't know why these methods don't work and why it's always better for us to enter the predictors in a sequence that is driven by theory and logic rather than letting the computer do that sequence for us.